Let's get ready for the Unit 13 test. One variable data and statistics. Make sure we show all our work and thinking. Circle your answers. Let's round everything to the nearest hundredth on this one, if that becomes necessary. And some of this should be done by hand without a graphing calculator. Now, when we say by hand, that means if you want to use a regular old basic calculator, that would be fine. Just not a graphing calculator that has all the statistics capabilities on it. So number one, it says find the descriptive statistics by hand. Those are listed down below here. And then create a box plot and a histogram. So let's go ahead and take a look at this. First thing we notice is it's not in order. So we want to go ahead and put this in order. So let's see. We got a 107 here. So I'm going to go ahead and write that. Cross that one off. 108. Okay, so those two happen to be in order. I'll cross that one off. And then let's go through here and find the next one. So we'd have another 108. So we'll do a 108 right here. And then we've got, let's see, we've got a 114. So 114. And we've got a 115. And again, notice how I'm kind of keeping these lined up with the ones up above. That kind of helps me know that I've got everything. And then we've got a 120. So we'll do a 120 right here. Then we've got a 129. So we'll write a 129 right there. And let's see, we've got a 132, 132, and then we've got a 140, 140, and then we've got a 158. Okay, so it looks like we've got them all lined up here. I'm going to go ahead and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So on this one, we'll mark off to the side here that n equals 10. That may come in handy later on. So if we're going to find the mean, we've got to add all these up, and then we've got to divide by 10. So let's go ahead and add them up. I'm going to bring up the calculator here. I'll shrink the size of this. And we've got to type those in there. So we're going to do 107 plus 108 plus 108. And again, because this is going to go off the screen here, it would be a good idea to double check as we are typing things in that we got it right here. So this is going to be 120, 129, 132, 140, and 158. Okay, so I think we got all those. It adds up to 1231, and we're going to divide by 10. So divide by 10, and we end up with 123.1. So we've got 123.1. And then we want to find the median. The median is going to be the middle here. So remember, there are 10, so we're going to do 10 plus 1 divided by 2. That's that n plus 1 divided by 2. So we get 11 divided by 2. That's going to be 5.5. That means it's going to be between the fifth one and the sixth one. So 1, 2, 3, 4, 5, 6. So it's going to be right in between here. So I'm just going to write median right there. So the median would be in between 115 and 120. So we'll have to average the two of those. So we'll do 115 plus 120. We'll divide that by 2. Now, I do want to show you one quick thing that people often forget. A lot of times students will do this. They'll do 115 plus 120, and then they'll hit divide by 2, and they say the answer is 175. Okay, there's no way that the median in between 115 and 120 is going to be 175, and here's the problem. The calculator knows the order of operations, so when you type it in like this over here, it thinks that you want to do 120 divided by 2 and then add 115. That's not what we want. So the proper way to do this is to do, let's see, we're going to do parentheses, parentheses 115 plus 120, and then we're going to divide by 2. Okay, so we'll hit divide by 2, and we get 117.5. So the median on this is 117.5. Now that's perfectly good. If you wanted to, you could do 115 plus 120, get the answer, then divide by 2. Either way, you're going to get 117.5. Let's see if there's a mode here. Is there one that occurs most often? There is, so we've got a 108. So there is one mode. Remember, if there are two modes, we'd want to list those. That would be bimodal. And then if there are three, we'd call that trimodal. And then after that, if there's a whole bunch of modes, then we just say it's multimodal. So we'll see if we come across something like that. And then let's do the min. The min is 107. Whoops. The min is 107, so that's this one right here. So the min is there. The max, I like doing it this way, so the max is 158, so 158. The median is the same as Q2, so that's going to be 117.5. And then Q1 is going to be the median of the bottom half. So I'm going to cross off this top half right here. and we want to find the median of this right here. So let's see, we've got 5 pieces of data. 5 plus 1 would be 6. 6 divided by 2 would be 3. So it's going to be the third one in. It's going to be this one right there. Or the other way you can do this is you can just kind of cross these off as you go through, and then we'd see that, oh, that's got to be it right there. It's got to be the 108. So I'm going to get rid of those little marks that I made there. And I'm going to put a line toward this one right here. This is going to be Q1, so this is going to be 108. And then we'll do the same thing on the top side. We'll ignore this bottom, we'll ignore this bottom half of the data. So we'll ignore all of that. And we want to find the third one in here, or again, marking those off. Either way, we end up with 132. So we'll mark 132 right here for Q3. And then the range is going to be the max minus the min. So that's going to be 158 minus 107. And again, I'm just going to use the calculator to make sure we get that right. Although that should be pretty easy, 51. So we get 51 right here. And then the IQR is Q3 minus Q1. So that's going to be 132 minus 108. So if I do 132 minus 108, we end up with 24. So the IQR, the interquartile range as we call it, that's going to be 24. So we're going to come down here and we're going to make a box plot. It says be sure to scale the axes. You do not need to use all the tick marks, and there may not be enough tick marks. So let's take a look at the data up here. So we've got 107 all the way up to 158. So if we were to start right here and call this 100 and then say 105 and 110, 115 and so forth, let's see, this would be 15, 20, 25, 30, 35, 40, 45, 50. That would not give us enough to fit that 158 in there. So there are a couple different things that we could do. We could count by tens. That would be a perfectly good way to do it. Or we could do this. I'm going to put a mark in between each one of these. So we'll just do it like this. Okay. And when we do each one of these marks, each one of those is going to count for 5. So we're going to go 100, and then this is going to be 105. This would be 110, and this would be 115. This would be 125, 135, 145, 155. And this would be 165 and so forth, okay? So that gives us plenty there. Again, this is not the only way to do it. This is just one way to do it. The vertical axis here doesn't make any difference at all. So let's go ahead and do the box plot on this one. So let's do the box to start off with. So we're going to go from 108. So I'll do a little line right here. So 108 about right there, because that would be 110. And let's see, 117 and a half. That would be about right there. And then 132, this is 125, 130, so 132 would be about right there. So we'll close that in, make it look like that. And then the max is 158, so we'll put a little mark right here. And the min is 107, so we'll put a little mark right here. And we draw those horizontal lines from Q1 down to the min and Q3 up to the max, and that's what it looks like. And then it says, pardon me, which quartile is the least spread out? Well, this quartile right here, that first quarter of the data, that's really compact. So we're going to say that that's Q1. And then which quartile is the most spread out? Which one has the most variation? Well, that would be Q4. Okay, and we can say Q1 and Q4, or we could say first quartile and third quarter or fourth quartile and so forth. So let's come down here and let's take a look at this one. This one says use the same scale as the axes up above. So I'm going to go ahead and mark this here as 105 and 115 and 125 and 135 and 145 and 155 and 165. So again, I'll do 105 here, 115 here. This can be a little tedious and time consuming, but it kind of demonstrates that you know exactly what's going on. 155 and 165. And again, just one more time, this is not the only way to do it. If you wanted to use tens, do a scale of 10, that would be totally okay. So one thing I'm going to do to make this histogram is I'm just going to put a list of the data right here so that we can make some decisions about this. So I just copied this from up above. And let's take a look here. How do we want to break this up? Well, if we go in groups of 10, we could say from 105 to say 115 right here. we've got 1, 2, 3, 4 pieces of data. But you'll notice that we don't have enough to count up here. So what we could do is we could say this is 1, this is 2, there's 3, there's 4, there's 5, there's 6. So for this first rectangle, let's say we're going to go from 105 to 115. Now, there are lots of different ways to do this, but I'm going to include 105 and be just short of 115. So that would include all 4 of these right here. So we're going to say that there are 4 pieces of data between 105 and 115. Again, we're including this lower one. We're not including this upper one right here. And then between 115 and 125, we've got those 2. So we're going to have a rectangle that comes up to a height of 2. And then between 125 and 135, we've got these 2, so it'll look like that. And then we've got one in the from 135 to 145. Okay, we've only got one, just this guy right here. And then we've got 158. Now 158 is actually in this class over here, this interval over here, so it looks like that. So that's what our display looks like. And because these are scaled the same, you can kind of tell we've got this kind of long tail here. So this is going to be right skewed. So we're going to write right skewed here, right skewed. And one way that we know that, we can double check using the data. We can see it using the tail, but take a look at this. The mean is bigger than the median. Okay, so we're going to write that down. We can see it on the display, but we're going to write down that the mean is greater than the median. Okay, and the tail is on the right. Okay, so tail on the right. Okay, so that would be our reason there. So let's go ahead and take a look at the other side here and see how that one works out. Okay, the instructions on this one are the same, so let's get going on this one. We want to find the smallest one because we want to put these in order, ascending order, so we can find the median. So the smallest one's going to be 49, so I'm going to write a 49 right here and cross the other ones off. Let's see, we've got a 51. Let's see, we've got a 56. We've got a 63. Got that one. We've got a 65. We've got a, let's see what's next, 71. Then we've got a 75, and then we've got an 81, and we've got an 87. Okay, now I'll come back in here and put commas in there, just make sure all that looks right. Okay, and you'll notice that we've got the right number of each. So we've got 1, 2, 3, 4, 5, 6. We've got n equals 9 on this one, so slightly different. So here's our data all in order. Let's go ahead and find the mean. So we can find the mean by pulling up the calculator here. So we're going to type this stuff in, and we just need to be careful on this. So we're going to type in 49 plus 51 plus 56 plus 63 plus, that is a 65. Whoops, 65 coming next. Then we've got a 71. And again, if you double check as you're going through there and make sure that you've typed them in right, that's going to save yourself a lot of grief in the long run. Looks like we've got everything in the right way so far. We've got our 71, then we're going to do our plus 75. Plus 81 plus 87, and then we'll hit enter. So our sum is 598. Then we're just going to divide that by 9 because we've got our n right here of 9. So here's our mean, 66.44. Again, we'll go to the nearest hundredth. Okay, now we want to find a median. Let's see, there are 9 of them. So if we do 9 plus 1 divided by 2, we get 10 divided by 2, and we end up with 5. That's going to be the 5th one. So 1, 2, 3, 4, 5. This one right here, that's the median. Okay, our min is over here. Our max is over here. And then our quartile, so this is interesting on this one. I'm going to go ahead and cross off on this one. Again, I'll cross off the top part of this. We've only got 4 pieces of data. So the Q1 is going to be in between the second one and the third one. So we have to average the 2 of those. So we're going to do 51 plus 56 divided by 2. Make sure you type that in the right way. I'll do 51 plus 56, get the answer, then divide by 2. Okay, so that's going to be 53.5. So I'll write that down here, 53.5. So right in between there. And then on this top half, again, ignoring the bottom half of the data on this, So right there, it's going to be in between the second and third one in that top half, so in between 75 and 81. I'm going to do this by doing 75 plus 81, put that in parentheses, so it'll find that answer, then divide it by 2. I end up with 78, so I'm going to put 78 here for Q3. So 78 for Q3. So we'll come back here and let's fill in the rest of the information. So the median is going to be 65 on this one, okay, right there. The mode, let's go through and check, does any one occur more often than another? Then the answer on this one is no mode, okay, or we could just say there's none. Remember, we can have no mode, we can have a mode, bimodal, trimodal, multimodal, all that sort of stuff. Minimum here is 49. Q2, same as the median, so that's 65. Max is 87, and then let's find the range. The range is going to be 87 minus 49, so 87 minus 49, and we end up with 38. So 38 for the range. And then the IQR, that's going to be Q3 minus Q1, so 78 minus 53.5. So 78 minus 53.5, and we end up with 24.5. So 24.5. And then we'll go ahead and make the box plot on this one. So let's see, we've got to go from 49 all the way up to 87. So maybe on the low end 45 and on the top end maybe 90. So let's see if this would work. If we did 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, that would work. So let's do 45, 50, 55, 60, 65, 70, 75, 80, 85, and this would be 90. Again, don't need to worry about the vertical axis on a box plot here. So let's see, let's do the box first. So we're going to go from 53.5, so that's going to be about right here. 65 for the median, 78 for the Q3, so that's the top of our box there. And then the min is 49, so 49 is going to be about right here. And then the max is going to be at 87. 87 is going to be about right there. Okay, so that looks pretty good. It says find the upper and lower fences to test for outliers. So remember, this is going to be Q1 minus 1.5 times the IQR. And the upper fence is going to be Q3 plus 1.5 times the IQR. So IQR here. So that's going to be Q1 is 53.5 minus 1.5 times 24.5. So we end up with, let's see if I type that into the calculator, 53.5 minus 1.5 times 24.5, and we end up with 16.75. So the lower fence is 16.75. So that would be way off the charts right here, and all the data is above that. Okay, so we're in good shape there. And then Q3, that's going to be 78. So we'll grab the 78, and then we add 1.5 times the IQR of 24.5. Okay, now here's something cool. I'm going to hit second enter to recall this. Since all I need to do is change a couple of things here, I'm going to change that to a 78. I'm going to hit a plus, and then I'm just going to hit delete until we're there. So 78 plus 1.5 times the IQR. Hit enter, we get 114.75. So the upper fence is 114.75, and 114 would be way up here off the scale. So are there any outliers? Not a single one. There are no outliers on this one. Okay, so we've got the upper fence right here, the lower fence right here, so we'll go ahead and put a box around that. And then we'll come down toward the bottom here, and let's go ahead and make the histogram for this one. So I'm going to go ahead and paste this data that I saved from up above. And let's use the same scale that we did up here, because that just makes things look better. So we're going to do 45, 50, 55, 60, 65, 70, 75, 80, 85, and 90. And let's do these in groups of 5. So again, we're going to include 45, and we're going to go up to like 49.999, just a little bit less than 50, but there's only one of those. Okay, so we're going to go like that. And then from 50 to 55, there's only one of those. From 55 to 60, there's only one of those. From 60 to 65, only one of those. Now again, this is 65. It's not going to be included in this one. It's going to fall into this next category, this next interval, this next class. So we've got that one right there. 71 would be from 70 to 75. Again, 75 is going to fall into this one right here. 81 is going to fall into that one, and 87 is going to fall into this right between 85 and 90. So if you take a look at this, my gosh, this could not get any more uniform. This is just 1, 1, 1, 1, 1, a height of 1 all the way along here as we look at that. So we're going to say this is symmetric and uniform. Okay, and let's just double check and see how close we are on this one. Remember, the mean and the median, if they're pretty close, and again, you might look at this and say, oh, that's 65 and the mean is 66. They're not very close, but look how big the data is. The data is actually pretty large. We go from 49 up to 87. So having them be 165 and the other one around 66, pretty close. So we're going to just say this. We're going to say the mean is approximately equal to the median, and then no tails. So no tails. And no outliers. It doesn't look like anything weird happened here. Even looking at these two distributions, we look like we're in pretty good shape, okay? All right, let's go ahead and take a look at the next page. Okay, on the back side here on 3 and 4, this is where it gets a little bit interesting. We've got to find the standard deviation by hand without using a graphing calculator. So what I've got over here, I've got a graphing calculator up, but I'm going to go ahead and pull up a different calculator. I'm going to pull up one that's not a graphing calculator, and we'll go ahead and do this problem using that. So remember, the first thing we've got to do is we've got to find the mean. So let's do the mean so we can fill it in the table here. So we're going to do 12.1 plus 12.6 plus 12.1. Whoops, I got to get the decimal in there, 12.1. And again, because this is going to end up off the screen, we want to make sure that we're typing things in correctly while we go. So 0.7 and then plus 12.3 plus 12.8 plus 12.2 plus 12.4, and let me get that 4 in there. Okay, looks good. We're going to go ahead and hit enter. And we got 87.2. Okay, so our answer right there is 87.2, but remember, we've got 8 pieces of data here. So I'm going to write n equals 8 on this one. So we've got 87.2, and we're going to divide by 8, and let's see what ends up happening here. So we'll hit divide by 8, and we end up with 10.9. So we'll do 10.9 for each one of these. So I'm going to go ahead and write down 10.9 here, and then I'm just going to draw a line down to the bottom. Every single one of these are 10.9. So again, I would rely on a calculator to make sure that you get these right. You could do it in your head, but it's just not worth it. So I'm going to go ahead and do 12.1 minus 10.9. It's always going to be the data minus the mean. So I'll hit enter. We end up with 1.2. So 1.2, which makes sense because that's above the mean. And then we're going to do 12.6 minus 10.9. Okay, so that's 1.7, 1.7, and 12.1 minus 10.9, and you'll notice that that problem is the same as the one up above, so we could have just written down the 1.2. Then we've got a 0.7 minus 10.9. Now this is going to be a big number right here, and it's going to be negative, so we get negative 10.2 because that's way below the mean, so 10.2. And the next one, we're going to have 12.3 minus the 10.9. So we get 1.4. So 1.4 here. 12.8 minus the 10.9. We end up with 1.9. 1.9 there. And then we've got 12.2 minus 10.9. We got 1.3. And then we're finally to the last one, 12.4 minus 10.9. I realize this gets tedious, but we've got a 1.5. So then we're going to take every single one of those and we're going to square them. Notice that the only one that's negative is this one right here. The rest of them you can just square whatever they are. So I'm going to go ahead and do that really quickly and we'll be back. Okay, so I've gone ahead and filled in all of the squared deviations. Now we're going to add those together, so I won't bore you with the calculations, but I'll add those together off screen. And we're back, added those together. We got 119.32. 119.32. So remember, to find the variance, we're just going to take 119.32 and we're going to divide by n. So 119.32 divided by 8. Divide by 8. and we end up with 14.915. So we're going to write down an answer of 14 point, and this is going to be either 0.91 or 92. We're going to do 14.92, but we're going to leave the answer in decimal form on the calculator with all that accuracy. So that's our variance, and then the standard deviation is just the square root of that. So I'm going to hit the square root button and grab that last answer, hop outside here, hit enter, and we get 3.86. Again, that 1's not enough to bump it up, so we're going to call this a standard deviation of 3.86. So we'll go ahead and circle that. Now, let's say that the median of this distribution, this data right here, is 12.25. So let's think about this. The mean is 10.9 and the median is 12.25. So we've got the mean of 10.9 and then the median of 12.25. So the mean is less than the median. So what that means is this would be skewed in the direction of the mean. So we're going to go ahead and say that this is left skewed. Left skewed. We'll write that down. That's our answer there. Okay, now it might be possible that there are some outliers in here or something like that. We're not going to get technical or anything. In fact, you may see that there's an outlier. This is way below the mean, and that kind of drug that, way below the other pieces of data, so that kind of drug the mean down there. But that's what we're going to leave on that one. So we're going to slide down here, and we're going to take a look at the calculations here. So I'm going to calculate the mean really quickly on the calculator. Then I'll come back and do each one of these. So I'll go ahead and find the mean and see if you get the same thing that I get. Okay, go ahead and take a look. I got a sum of 2,380, and when I divided by 7, because there are 7 pieces of data, remember n on this one is 7, I got 340. So we're going to go ahead and do 340 for each one of these. So there's 340 for each one of those, and then we're going to find out the deviation. So we're going to do the data minus the mean. I'll do the first one with you, and then we'll just take some time over here and do it off screen. So we're going to do 184 minus 340, and we end up with negative 156. So I'm going to write negative 156 for this one, then I'll fill out these other ones. You go ahead. Okay, if you did these right, here are all the deviations. Now we're going to square each one of these. So I'm going to go ahead and take that negative 156. And remember, when we square them, they turn out to be positive. So I'm just going to do 156 and I'm going to square it. We end up with 24,336. So 24,336. I'm going to get all these answers off screen and then be back in just a second. Okay, we've squared all of those, and now we're going to add those up to find the sum. So I'll go ahead and do that on there. You go ahead and do it, and then we'll double check. Okay, added those up. We got 328,492. So 328,492. And now all the tough calculations are done. Variance is just going to be that number divided by, what do we got, 7 here. So we're going to take that answer, divide by 7. So we end up with a variance of 46,927 and then 0.42. So either 42 or 43. That's going to be 43. So we're going to do 46,927.43. So there's our variance. Our standard deviation, again, we leave the decimal accuracy in here. We're going to take the square root of that last answer. Hop outside there, and we end up with 216.62, and again, that's going to round up to a 3 also. So we've got 216.63, so 216.63 for our standard deviation. And then it said if the median of the data above is 294, what can you say about the shape of the distribution? Well, what we've got here is we've got a, let's see, a median, and then we've got the mean over here. So we've got 294 for the median, and we've got 340 for the mean. So since the mean is bigger, this is going to be skewed to the right. So we're going to write right skewed. And again, there may be other things going on. We may have outliers that are dragging that mean way above the median. Remember, the mean is very sensitive to outliers, so we want to be a little bit careful with that. Okay, good. We're done with the stuff by hand. Now we're going to go ahead and use the graphing calculator for the rest of this. Okay, last page on here, we can do this with a graphing calculator. So I'm going to go ahead and bring in the graphing calculator on this one. And the first thing we're going to want to do is we're going to want to put this data in here. And then we've got to find the mean, median, standard deviation. So the calculator is going to be like our total best friend on this. So I'm going to go ahead and hit stat, and then we're going to edit using number 1. I've got some old stuff on here, so I'm going to go ahead and clear that off. So we just hop on the name of the list, hit clear, and hit enter. So we'll hop up there. Now you can also reset the calculator. That's a great way to do this. So we're going to go ahead and put in 100, and then we're going to put in 89, and then 112, and then 104, and then 96, and then 108, and then 93. Okay, so we've got those in there. Now let's just double check. We've got 7 pieces of data in here, and notice that we've got 7 of them. Again, if you don't put it in the right way, you're going to get the wrong answer. So let's be careful with this. So we're going to go ahead and hit second quit, and we want to find the mean, median, and standard deviations. So I'll get back to the home screen, and in order to do that, we're going to hit Stat, Calc, one variable statistics. I'm on an 84 here, so it looks a little bit different. If you're on an 83, you should be able to follow the instructions for that. And we're going to come down here and we're going to calculate that quickly. Take a look here. We've got the mean. So X bar is 100, and then we're going to round this to hundredths place, so that's going to be a 29. So 100.29. The median will need to come down here. Oh, let's grab the standard deviation. That's that sigma. So we're going to call this 7.64 or 65. That's enough to bump it up. So 7.65 here. And then we'll come down here and we will find the median. The median happens to be 100. And that 5-number summary right here, that's what we need in order to make this graph. So we've got data that goes from as small as 89 all the way up to 112. So let's do this. Let's count this as 85, and then if we do 90 here, 95, 100, 105, 110, and then 115, and then 120, and 125, that's going to give us plenty there because the largest one that we've got here is a 112. So we're going to go from the min of 89, so 89 would be about right there. I'm just going to make a small mark here. The Q1 is 93, so 93, I'm going to make that a little bit bigger right there. Let me move that back so it looks a little bit better about where 93 would be. Okay, so we'll go about right there. And then the median is 100, so we're going to be here. And then Q3 is 108, so 108 is going to be about right there. And then the max is 112, so that's going to end up right here. So we'll go ahead and close in that box. Go here, go here. So we've got that all taken care of. And it really didn't take very long because we used the calculator to calculate all these numbers for us. Let's take a look at the next one. And this one, it wants us to draw a histogram. So let's go back to Stat. And I'm going to edit. And I'm going to leave that information in there just in case I need to go back to it. So we're going to type in 27, 35, 22, 31. And the awesome thing about this is it doesn't have to be in order. Whoops, I don't need another 35. We can put it in just in the order that it's in the list, and we'll be in great shape here. Okay, so let's take a look here. I've got 9 pieces of data. Let's check and see. I've got 3 here, so I do need 9. 34, 24, 25, 20, 35, 31. Looks like we're in good shape there. Again, we got to get this in right. Let's see, and then 27, 35, 22, 31. Okay, so I think we're in good shape there. We're going to hit second quit. We're going to go to calculate. Whoops, second quit. Oh, clear. Let me make sure I get this right. Stat, and then we're going to calculate. There we go. So we've got one variable statistics. We're going to tell this is in L2. If you want to put them always in L1, that's fine. And we're going to come down here and we're going to tell it to calculate. So here's what we get for a mean. So there's X bar, the mean, 28.1 repeated. So that's going to stay 28.11. Let's see, the standard deviation is 5.46 or 47. We're going to say 5.47. So 5.47. And then the median will come down here and we'll get that. Median is 27, so 27 here. Now, we want to have the calculator help us draw this. So I'm going to go ahead and hit second and y equals for the stat plots. Now, you'll notice that plot number 2 shows that it's on also. This is why it's a really good idea to make sure that you've reset your calculator so that things don't get messed up. So I'm going to come down here to plot number 2, and I'm going to go ahead and turn that off so we don't have to mess around with it. Come up here on plot number 1. That is already on. We're going to have a histogram, and we're using, let's see, for this one we're using L2. So I'm going to go ahead and hit second L2. Again, like I said before, if you want to do everything in L1, that's totally fine. So let's go ahead and set up the window here. Oops, we'll hit window, there we are. Okay, and we need this to go from the smallest one looks like it's about 20 and the biggest one looks like it's about 25. So I'm going to go from 15 up to maybe 40, make sure we can fit everything in there. And I'm going to do a scale that goes by 5s. And the next minimum of -1, that's okay, and a 5. We don't expect any of these boxes to be taller than 5. But let's go ahead and hit graph and see what it looks like. Okay, that's not too bad. You can also hit trace, and we can go through here. I'd like to get a little bit more descriptive information about what's going on this one. So let's go ahead and hit window, and I'm going to go from, let's say we go from, the smallest one is 20, and the biggest one is, let's see, what do we got here? Biggest one is 35. So we're going to go to, say, 36, and I'm going to go by 2s, okay? So let's see what that looks like. Okay, so a little bit different picture. Again, lots of different ways to do it. It's not that the first one would have been wrong. That one would have been totally okay. So here's what we're going to do. We're going to start down here at 20, and we're going to go 22, 24, 26, 28, 30, 32, and 34, and 36. And let's take a look at what happens here. So we've got, let's see, in the trace, so from 20 to 22 we've got 1. So we'll make it look like this. Okay. From 22 to 24 we've got another 1. Okay, and my boxes look really crappy. From 22 to 26 we've got 2 of them. So we'll make that go up twice as tall as the other ones. We've got another 1 right here. We don't have any between 28 and 30, but between 30 and 32. Okay, and none between 32 and 34. You can see that right there. And then we have 3 in between 34 and 36. So that needs to be about this tall right here. Okay, again, not the only way to do this one, but that's a decent way. Again, if you've got your scale on there, that's going to be totally fine. And then I'm going to slide down here and we're going to take a look at this one. I don't think we need a calculator for any of these, so I'm going to go ahead and go full screen on this one. It says, for the displays below, which phrase best describes the distribution? Skewed right, skewed left, symmetric and bell-shaped, or symmetric and uniform? Draw and label the vertical lines to show the approximate location of the mean and median for each distribution. I'm going to underline approximate. It doesn't have to be perfect. And then we want to say whether x bar and sigma, so the mean and standard deviation, or the median range and IQR would be the best measure of center and spread. So just some general ideas here. Remember, the mean and the standard deviation, those are going to be used if we've got a symmetric distribution, either symmetric and bell shape or symmetric and uniform. And if we've got it skewed one way or the other, then we're going to use the median and the range and the IQR. So let's take a look at this one right here. On this one is symmetric and bell-shaped. Okay, that's the first thing. We want to show lines for the approximate location. Gosh, this looks really good. So I think both the median and the mean, so I'm going to put mean and median. Those are both in roughly the same place on this one. And because it's symmetric and bell shape, we're going to use x bar and we're going to use sigma for the measure of center and spread there. Let's take a look at this box plot right here. So you'll notice that on this one, we've got a long tail on this one. So this is skewed in the direction of the tail. So this is going to be left skewed. So left skewed takes care of that. We want to have the approximate location of the mean and the median. Well, remember the center of the box, that's going to be the median. And then I'm going to do a vertical line. It gets drug in the direction of the tail here. So I'll do a vertical line here and I'll say that that's roughly where the mean is. Again, it's approximate. It doesn't have to be perfect. And then the next thing we're going to say is the best measure of center and spread would be the median, range, and IQR for this one. Okay. All right, let's take a look down here. This is a histogram, and clearly you can see a tail that's going off to the right here. So we're going to say that this is, this is right skewed. So if we're going to draw where the median and the mean are, you kind of need to think of how tall each one of these blocks are, and we want to kind of add up enough blocks that we've got half of the blocks on one side and half of the blocks on the other side. So I'm going to say somewhere about right there. Sorry, that's a crappy line. That's going to be the median, and then the mean gets drug in the direction of the mean, or of the tail. So I'm going to write mean right here. And again, those lines are really crappy, so I'm going to redraw those. Okay, so I'm going to draw that so it looks like this. That looks a little better. And then maybe the mean about right there. And then this one, we also need to say what we're going to use here. Because this is skewed, we're going to use the median, the range, and the IQR. And IQR. That's going to be our measure of center, and range and IQR are going to be our measure of spread. This one right here, you can tell that this is symmetric and uniform. Symmetric and uniform. If we were to put a mean and a median on here, they're going to be pretty much in the same place. So I'm going to put median here, and I'm going to put mean up above. And then we would use, because we don't have any outliers or it's not skewed one way or the other, we're going to use X bar and sigma for measures of center and spread. Now, the only other thing that I want to add here is anybody looking at this can see where your mean and your median are. If you wanted to say that the mean is roughly equal to the median on each one of these, then that would be fine. So mean roughly equal to the median, then we'd be in pretty good shape. Okay, there we go. Good luck on the test. Make sure you study hard.